The following video is about converting points from rectangular to polar form and from polar form to rectangular form. The first thing we have to do is understand what the polar form of a coordinate is. The polar form of a coordinate is r theta. So instead of writing things as x comma y when we're writing things in polar coordinates, we write them as r comma theta. R is a radius, and we can write it as either a positive or negative number, and we'll show what that looks like in a second. And theta is the angle measure, just as we always do it. So pi thirds would be moving in this direction. Negative pi thirds would be moving in that direction. Then we take a look at some of the things that we've known for a long time. So x squared plus y squared equals r squared is just a Pythagorean theorem right triangle situation. And we can rewrite that as r equals the square root of x squared plus y squared. So that's one way to solve for r. We know that cosine of theta is x over r. We can rewrite that as x equals r cosine theta, where if we are in polar form, we can then solve for x. Likewise, the same thing is true about sine with y over r. So we can solve that for y, and if we have something in polar form, we can get it into rectangular form. Then we also know that tangent is y over x. So if we have an x and y coordinates, we can end up getting theta from that. So usually what we do is the top two are the situations we use to convert from rectangular to polar. And the bottom two, x equals r cosine theta and y equals r sine theta, are ways that we convert from polar to rectangular. So now let's do some examples. We're going to plot the following points. We're going to plot 4 comma pi thirds. So what we want to do is we want to plot a radius of 4 at an angle of pi thirds. And so that would look like this. Notice that the radius is 4. 1, 2, 3, 4. And then there's a circle with a radius of 4 all the way around. So this is 4 comma pi thirds. 4 comma negative pi thirds would be going on the circle of length 4, radius 4, but going in the direction toward negative pi thirds. So that would be this way. So this one would be 4 negative pi thirds. Negative 4 comma pi thirds would be going pi thirds, which would be up here. And then instead of going in the positive direction for the radius, we're going to go in the negative direction for the radius. So that's going to be the purple point. Negative 4 pi thirds. And finally, negative 4 negative pi thirds would be going negative pi thirds, but instead of going a radius of 4, we're going to go in the opposite direction and go a radius of negative 4. So the blue point would be negative 4 negative pi thirds. Now we can actually write these points in a variety of different ways. So what I'm going to do right now is I'm going to take each of the green, purple, and blue points and write them in a different way. So I could write the green point as 4 comma 5 pi thirds. I could write the blue point as 4 2 pi thirds. I could write the purple point as 4 pi thirds. I could also write all of these with a negative radius. So I could write the green one as negative 4 negative 4 2 pi thirds, because it's 2 pi thirds would be up here, and I can go in the opposite direction with a radius. So there's a lot of different ways that I can do these types of problems. I could also write the red one, for example, as negative 4 pi thirds. So there's a lot of different ways we can do it. Now, let's convert from rectangular to polar. So we're going to convert each of these points to polar. First, let's plot them. So I'll plot 1, 2, negative 3, 1, 4, negative 1, and negative 2, negative 3. So what we're going to do is we're going to convert each of these things. And remember, if we're converting something from rectangular to polar, we probably want to use these situations. So r equals the square root of x squared plus y squared, and theta is going to equal the arctangent of y over x. So let's go down here. 1, 2, I'm going to do r equals the square root of x squared plus y squared. So r would be square root of 5. And then theta, well, this is not a nice number, so it's not like I'm going to end up with pi sixths or pi thirds or something that we have memorized. So what I'm going to do is I'm going to say this is the arctangent of y over x. And we would just leave it as arctangent of 2. Now, negative 3, 1, we're going to do the same thing. R is going to be the square root of negative 3 squared, which is 9 plus 1. So this will be the square root of 10. Then I have the arctangent of negative 1/3. However, we have to be careful because remember that arctangent has domain restrictions and range restrictions. So arctangent is actually only showing up in the first and fourth quadrants. So if I need something that shows up in the second quadrant, I have to realize that if I put a negative y over x in for arctangent, that's going to get me an angle in the fourth quadrant. And if I want an angle in the second quadrant, I have to add pi. So it's arctangent of negative 1/3 plus pi. If the point is 4, negative 1, my radius would be the square root of 16 plus 1. So the square root is 17. And then I have arctangent of negative 1/4. Notice that that's where I end up with a theta. If I typed arctangent in the calculator, I get a fourth quadrant. So I'm not going to have to add any sort of angle. Finally, negative 2, negative 3, I end up with the square root of 2 squared plus 3 squared. And then if I plug in y and x, I get arctangent of 3/2. But remember, that's going to get me something in the first quadrant. And if I want something in the third quadrant, I have to add pi. So these would be the 4 points that I end up getting. Now let's convert 6 more points and call it a day. These are from rectangular to polar. So if I'm going to plot negative 2, 2 root 3, well, I could go negative 2 to root 3 and try and guess where 2 root 3 is. Or what I could do is I could end up converting things. So if I want r, that's going to be the square root of negative 2 squared plus 2 root 3 squared. So that would be 4 plus 2 squared is 4 times 3, so 12. So that's the square root of 16. So r equals 4. Well, that actually makes some sense, and it hopefully should make some sense because we should know that this is a 30, 60, 90 triangle, right? So if my x is 2 and my y is 2 root 3, I should end up with a radius of 4. That's just something that I probably should know by now, knowing 30, 60, 90 triangles. And then that means that my theta, I could do arctangent of 2 pi thirds over negative 2, which gives me arctangent of negative root 3. Remember that I have to add pi, but I should also know that that is just 2 pi thirds if I know my unit circle. So I end up with 4, 2 pi thirds. I can write this point in several other ways. I can write it as 4 negative 4 pi thirds, or I could write it as negative 4 5 pi thirds, or I could write it as negative 4 negative pi thirds. There's a lot of different ways that I could write it, because if I go negative pi thirds and then I go in the opposite direction, it would be over there. So there's a lot of different ways that I could write this point. Negative 1, negative 3, well, that's actually easy to plot because I just plotted exactly where negative 1 and negative 3 are on these radii circles. But now I have to do an r and a theta. So r is equal to the square root of 1 plus 9, square root of 1 squared plus 3 squared. And then theta, it's in the third quadrant, so I know I'm going to have to add pi. So that's arctan of 3 plus pi. So square root of 10, arctangent of 3 plus pi. And that doesn't end up being a nice angle. Now I could do some other ones, so I'll name one other point. So negative root 10, arctangent of 3. So if I don't add pi, that means I get a first quadrant angle. And so that would be over here somewhere. And if I do that, I could just do the negative radius in order to put it down there. 3, negative 3. If I think about that, 1, 2, 3, 1, 2, 3, I should realize that that's a 45, 45, 90 triangle. So that should be about here. Now, if I just confirm that, I get the square root of 18, 3 squared plus 3 squared, which is 3 root 2. So 1, 1 square root of 2 type of triangle. And then theta, I could get arctangent of negative 1, but I should know that's negative pi fourths or 7 pi over 4. So I end up with 3 root 2, 7 pi fourths, or 3 root 2, negative pi fourths, or I could say something like negative 3 root 2, 3 pi fourths. There are a lot of different ways that you can write this point. Last thing we're going to do is convert polar to rectangular. So in order to do that, we're going to use x equals r cosine theta and y equals r sine theta. So x equals 8 cosine of pi sixths, and y equals 8 sine of pi sixths. So that's 4 root 3, 4. So if I do 4 root 3, 4, it ends up being a 30, 60, 90 triangle. And 4 root 3 is about 7-ish, somewhere around 7. So it ends up being a point over here. If I want to find another way to name the point in polar coordinates, I could say negative 8, and then an angle over here like 7 pi sixths. Number 5, negative 7 3 pi fourths. So that's going to be, instead of at 3 pi fourths, remember it's going in the opposite direction. So it might even be easier to just rename it now to be 7 pi fourths. So that's going to be down here. And that's going to be a 45-degree angle. So if I do x equals 7 cosine of 7 pi fourths, and y is the sine of 7 pi fourths times 7, I end up with 7 root 2 over 2, 7 root 2 over 2, with the y part being negative. So this would be 7 root 2 over 2. This would be also 7 halves root 2. Finally, problem 6, we can use x equals r cosine theta and y equals r sine theta. But it might help to understand what's happening with arctangent of 1.5 plus pi. So y over x is on the inside of the arctangent, so that means y over x equals 3 halves. That would give us a first quadrant angle, but then the plus pi rotates it, so now we have a third quadrant angle. So I should be aware that this means third quadrant angle. Then, if I have arctangent is 1.5, that basically means that my ratio of y to x is 3 over 2. And if I do r equals 2 root 13, that means that 3 squared plus 2 squared is root 13. Everything's just going to be multiplied by 2. So my ratio of 3 to 2 means that my y is going to be 6 and my x is going to be 4. Or I could actually just plug the things into the formula in order to get them. Now, if arctangent 3 halves plus pi is in the third quadrant, I take the sine of that. I'm just going to get back the y part because the root 13s are going to cancel. And likewise with the x, the root 13s are going to cancel. So I end up with -4, -6 as my point.